Open RAN is hot. Different vendors have different recipes to cater to this market. Today we look at a vendor that is leveraging the power of GPUs in its RAN architecture. We are talking about Fujitsu. Kaushik Sinha, head of Fujitsu Research India, spoke to Kaustubha Parkhi, principal analyst Insight Research, on this and a variety of related topics. In this segment, Kaushik brings forth the methodologies adopted by Fujitsu in ensuring improvements in operational parameters such as power consumption, as well as in the overall TCO. Let's listen in.
So, one of the major, announcements that was made with this particular product launch was very impressive improvements in, total cost of ownership, power consumption, and network design utilization metrics. So, can you shed some light on how the VCU and VDU have contributed to these enhancements?
Yeah, sure. So, energy efficiency and power consumption are topics which are very common across industry, ORAN, 3GPP everywhere, especially Fujitsu, because we believe in a lot of concepts like regenerative organizations. What it means typically is we want to give back to community, society, economy, and how we do that is we try to put solutions where energy can be saved, because we believe energy saving is key aspect towards long-term sustainability. And that's one of the guiding principles where we put a lot of our strategic technology roadmap and thinking. Having said that, there are multiple ways energy efficiency is being handled in our products. As you know, first of all, we have roadmap to support a lot of ARM-based architecture. Okay. And when we think long-term ARM-based, you already are planning to, do some testing on the servers like Supermicro, which are coming from Ampere ARM architecture. So that is one area where power can be saved, and there are proven numbers. And we talked about this in MWC 2024 as well. As per ARM, there are significant double-digit saving in power saving. Okay, ARM architecture. And it is not the secret. It is well known that ARM works on faster performance and then very quick instruction sets. That's the reason it is called a reduced instruction set. That's one aspect. But secondly, you rightly talked about CU software as well. So CU software will be hosted on ARM platforms. Okay, as well as we have power saving features which can reduce at the RU side configurations based on situation. For example, in 44R kind of configuration, we have two to four transmit paths. And if the requirement does not require 4 transmit paths, you can reduce to 2. So directly all the components in the transmit path, including high power consuming power amplifiers and then receive path, LNAs, etc., you can save significant power. So you're saving by CU software configuration, end-to-end RAN solution, RU power. On the server side, where CU software will be hosted, a lot of DU software hosted, you save power. As at the same time, GPUs also come with power saving functionalities. For example, either NVIDIA, Marvel, for that matter, any SoC comes with power saving. So we plan to utilize most of these features in most optimized way to save overall power. So multiple way we are addressing this, and these power saving features we have put together in our product roadmap. At the end of it, operator are going to get good benefit in double-digit power saving out of this.
Okay. So, power saving is mostly concerned with, OPEX, that is the operational expenditure. What about the Capex? I mean, this particular solution, since you are going for a GPU, which many believe is sometimes an overkill for, the kind of computing requirement that a base station entails. Would the initial cost be high? And in that case, how does the total cost of ownership work out? Any light you can shed on this?
Yeah. Yes. So there are other SoCs based acceleration also, because it did not always be, for example, GPU based, like NVIDIA solution based. How we have positioned our roadmap with these products is that any enterprise deployment, private RAN solution, it is required, then we can propose GPU based, where you gain out of AIML framework where you have a lot of AIML apps environment also. So that is one deployment where GPU can be used, and also it's a lot of flexible solution. You can use cluster of them, you can use only one of them, just one of them also. I understand it will cost will be at say few thousands or say 50,000 plus for one of them, but reality is that it is very high capacity. You can cluster many cells, you can enable a lot of high performance features, and you can customize it, and you can define slicing, a lot of things you can do. But on the other side, there are other acceleration solution on the SoC. They will not use exactly GPUs, but those are SoC based solution. Many of them are also coming from ARM enabled architecture. So that may be slightly cost effective solution. So we are open to support such also. I think one comes from Marvell as well.
Okay. So great. I mean, basically, it is a combination of using the right platform. In your case, ARM, which gives the power savings on the operational level, and then yeah, of course, there is always a trade-off between the additional features that one gets through GPU and the the incremental cost that one has to shell out.